Water. We use it every day without a second thought. Yet for billions of people around the world, access to clean, reliable fresh water is one of the defining challenges of our time. Climate change is intensifying droughts, populations are growing, and the pressure on our fresh water resources has never been greater. What makes this especially urgent is where people live. Most of the world's largest cities are coastal, and right now, 2.15 billion people live in the near coastal zone. That's more than 1 in 4 people on Earth living in areas that are already experiencing or projected to experience serious water stress. And nowhere is this felt more acutely than the Mediterranean, one of the world's most severe water stress hotspots. Take Malta, a small island nation in the heart of the Mediterranean, and one of the most water-stressed countries in the entire European Union. With virtually no rivers and limited rainfall, Malta depends heavily on energy-intensive desalination just to meet its water needs. But what if there's another option? One we haven't fully explored. What if there's another source of fresh water, hidden offshore, beneath the seafloor? So, my name is Ariel Thomas, and I'm a Marie Curie researcher at the University of Malta. My research is primarily about offshore fresh and groundwater. So this is fresh water that occurs in reservoirs beneath the ocean floor, which is not where you might expect to find it. And this is why I have dedicated my life to exploring this global phenomenon. And I'm currently part of 2 ongoing projects here at the University of Malta. One of them looks at the more technical aspects, trying to predict where these reservoirs may occur. And the other one is a more European collaboration where we try to determine what could be the social and economical impacts of this potential resource. So I got into this topic because of its potential global reach and impact. The search for new and innovative water resources or water resource strategies is a topic that could influence or impact many regions. And so I found this to be a very interesting field to get into. My background in the energy industry gave me a lot of the skill sets that were relevant for this. So when my supervisor brought it to me all those years ago during my PhD, I jumped right on it because I thought that it fit my desire to make a global impact. So before we speak about what's hidden beneath the seafloor, we need to talk about this, a sponge. So just bear with me. You're washing the dishes and you squeeze the sponge and water flows out. Where did that water come from? Well, it's stored in the tiny gaps inside of the sponge, and these are known as pores. Now imagine this sponge is a rock or gravel or sand, and there are kilometers of them beneath the surface, spread over very large distances. And that is sort of like the Earth's underground storage system. And that's what an aquifer is. So whenever we drill into the ground to get drinking water, when we drill a well, that's what we tap into. And this is what supplies much of the world's fresh water. Now here's where it gets interesting. You see all of that sea behind me? You see it and you think salt water, end of story. Well, actually, in many places around the world, scientists have discovered fresh water beneath the seafloor. And we found these in offshore New Jersey, offshore Australia, New Zealand, the South China Sea, and even parts of the Mediterranean, and right here offshore Malta. And so you might be asking yourself, how does this fresh water get there? So how does fresh water end up beneath the seafloor? Well, to answer that question, we have to go way back in time, around 20,000 years ago, to the last ice age. During these glacial periods, large amounts of water is stored as ice, and sea levels were as much as 120 meters lower than they are today. So all of that sea behind me was dry land. You could walk on it, rain falls on it, and this rainfall infiltrates into aquifers that we mentioned earlier. And they are stored there over several hundreds of years, while the sea level is much lower than today. Fast forward a few thousands of years, the planet warms, the ice melts, and sea level rises quite rapidly to our present day levels. And some of that fresh water is actually trapped because of the layering and the geology in the subsurface. And so today we are able to find large regions of fresh water holding large volumes beneath the seafloor. And this is what we investigate. How did it get there? What is the potential? And how could this possibly be used to help alleviate water stress in coastal regions and arid regions like the Mediterranean? So what we're talking about with offshore fresh and groundwater is actually an ancient freshwater that has been stored in the ground from a different climatic period. While that is scientifically fascinating, it can also have a very practical usage. Consider Malta, a tiny island with the highest water stress in the entire European Union. And Malta gets around 65% of its water supply from desalination. So I'm standing here next to one of Malta's largest desalination plants. And how this works is that they pump seawater and they use very high energy intensive pumps to drive this seawater through membranes to produce fresh drinkable water on the other end. Now, scientists have suggested that the water stored in these offshore reservoirs can actually be used as an alternative feed water for desalination plants like this one, which would allow it to reduce its carbon footprint, lower the energy intensity, as well as increase the potential output. So this is one of the practical or potential practical applications of offshore fresh and groundwater research. So my research in this field has two main tracks. A technical aspects, where we try to understand these systems and how they operate. So in the very same way we try to understand why there are clouds or how volcanoes work, we want to understand why are these offshore freshwater reservoirs occurring, how did they get there, and how much water is in these systems. And the other aspects are more socio-economic and related to the potential utilization of this resource. What are some of the environmental and economic challenges that might arise from the utilization in the future? And these together give us a good overview of offshore fresh and groundwater research here at the University of Malta. Now, regarding the technical aspects, this involves field work, so going out and taking measurements of the subsurface, usually done through wells that are dug into the ground. And we lower instruments into the ground to measure the type of rocks, the type of fluids, and these are then brought back to the lab to analyze, to interpret the data, to understand what's really going on in the field. And so that type of work is what I do a lot every day, and I could show you if you just join me over here. So I'm going to show you one of our projects, which is based offshore New Zealand on the Canterbury Bight. And so there's a lot going on the screen, so I'm going to try to break it down. Right here we have the South Island, and you can see this is the present sea level, so all here in blue. Now, 20,000 years ago, the sea level was much lower, which exposes this entire area of land. And we know from the well data, from boreholes, that there is offshore freshwater in that area today. So how do we test this hypothesis? How do we integrate the data? So we start over here by looking at the wells in the subsurface, which tells us where we have sand, where we have gravel. These are our aquifer layers that store water. And we get a nice map of the subsurface. And with this map, we're able to tell where the fresh water occurs. In order to take that into 3 dimensions, we use seismic data, which gives us a map of the layers in the subsurface in 3 dimensions. So I spend a lot of time interpreting these layers, staring at these, dreaming about them at night, and eventually you end up with a 3D model that gives you a distribution in the subsurface. So here on the left, you see a distribution of the different types of rocks in the subsurface. And then on the right, you see the simulation of the fresh and salt water interaction after various changes in the sea level. So the blue shows you where we have pockets of fresh water, and red represents the salt water. So this is just a quick overview of the modeling and integration of different types of data. So one of the projects I'm engaged in at the University of Malta is called Project Optimal, which is an acronym that stands for Offshore Fresh and Groundwater Prospecting Using Machine Learning. So that's a lot of words, and this project simply is meant to do 2 things. Develop a machine learning model to predict where offshore groundwater might occur, and then apply this model on a global scale in order to estimate the global volume of offshore fresh and groundwater. So you could think of this as a cost-effective, low-budget prospecting tool that you could deploy in different regions. So we're going to throw a lot of data at this and try to get a model that hopefully predicts where this resource may occur. So OffSource is an EU-funded scientific network that comprises of academic, private, and public sector participants. And this aims to address a common question. Can offshore fresh and groundwater be used as a potential resource in coastal regions? And we do this by addressing the key knowledge gaps in this field, which are both technical as well as legal, economic, as well as environmental. So we try to address these in different working groups. So we have assessment working groups, as well as innovation and methods, looking at how do we assess where the fresh water occurs, what are the best methods to use. Then we have working groups that are more interdisciplinary, looking at the potential for utilization or integration with existing strategies such as desalination. And finally, we have a working group that looks at the legal and economic challenges as well as environmental challenges. This is all underpinned by training schools, grants, and other scientific communication and dissemination activities around building and expanding the network and the awareness of this potential resource. Offshore fresh and groundwater has been proposed as a potential solution for water stress in coastal regions. However, it is no silver bullet. It is simply one innovative method that can be integrated with existing technologies, such as desalination, to help reduce the cost and reduce the carbon footprint of desalination operations, or it can be used as a standalone solution or as a strategic reserve. There are many options that can be considered. We need to fully understand these systems, what role they play in the global water cycle. Do they have some biological or ecological significance? All of these questions still need to be answered before we actually utilize this as a potential resource. So this research helps to close some of these knowledge gaps and help us better understand the role from a physical Earth system point of view, as well as the broader socio-economic implications of this resource.